This is Dubious Insights. I saw a pretty cool video by Sebastian Log and Peza, who did some ant colony simulations where the ants would go wander around and find food, and they drop pheromones and bring a colony there. And I wanted to try something like that. And turns out the first thing to do is to get the ants to wander around. So here are 20 ants wandering around. You can see they wander over the screen kind of randomly, but do make some progress. One thing I found with this is that the scale matters. So here I have these ants, and they're, I think, 124 pixels on a 1900 pixel screen. So real ants can move 10 times their body length every second. So a 1 centimeter ant can move 10 centimeters per second. And so to make that kind of look better, here it is on a bigger scale. So these ants are 1 centimeter each. There are 500 of them, and they're moving 10 centimeters per second. The inner ring is at 1 meter. The outer ring is at 5 meters. And they're leaving the trail behind them. You can see they explore the space pretty well. You know, they get out of 1 meter really fast, and they get out of 5 meters pretty fast. And from the research I've done on ants, you know, they can go collect food 100 meters away. I don't have the actual food collection, but the wandering works pretty well. So this is how I did the wandering. It's a single ant, and you can see it wandering around. So this is how the wandering works. The ant has a velocity, and what we want to do is make it pick a new direction that it wants to go every some period of time. We could do it every frame rate update. Here I'm doing it every 0.2 seconds, I think. The green line is what its current velocity is, and the red line is where it desires to go. And the way it's picking where it wants to go is it puts a circle out in front of it. So at some distance out in front of it, it puts a circle. And then it randomly picks a point on that circle that it desires to go to. And it'll now steer towards that point as though it accelerates towards that point. It still has velocity, so the velocity changes over time. It doesn't instantly change because we're applying acceleration to the velocity. The nice thing about this is a bunch of things you can tune with it to make it more realistic. So for instance, here are 3 different ants. The one on the kind of top left was similar to what the ant you just saw. Its circle is moderately close to it, a moderately sized circle. The one a little bit below it has a big circle that's fairly close to it. And the one on the right has a smaller circle that's farther away from it. And these ants will all have different behaviors. Unsurprisingly, this one on the far right, with the smaller circle farther away, has less random behavior. It goes more straight, you know, it still changes, but it has less random behavior. It kind of is more decisively picking. The one in the middle with the medium-sized circle, medium close to it, has more random behavior. It wanders around. It still covers pretty good distance, but it does wander around. And the one that has the circle that is pretty much all around it, you know, that's not too different from if it's just picking a random direction every 10th of a second. So it's really mostly just turning in circles and not making distance. The other thing you need, once you've picked a direction, you need it to go towards that direction. And so this is the kind of fundamental thing. This is the seek behavior. Before it was a wander behavior, and this is the seek behavior. And this ant is seeking to catch my mouse. The green line, once again, is where it's currently heading, and the red line is where it wants to go. And you can see as I move the mouse, the red line moves, and then the green line slowly catches up to it. How fast the green line catches up is how fast it can steer. And this is an example of three different ants that have different steering factors applied. One of them has a really fast, you know, it basically instantly catches up. One of them is medium fast, like we just saw, and one of them is really slow. So if I move the mouse, the one on the bottom there, you know, it basically immediately turns to follow the mouse. The one kind of in the middle, it turns, but it's a little bit slower. And the one that was more on the left, it's turning really slow. Probably unrealistically slow for an ant, but maybe that's appropriate for a boat or an elephant or something. The other behavior I thought was kind of cool when I was playing with this is that if you have a bunch of particles or things with the same steering behavior on them, and here they're following a mouse, eventually they all collapse down to one because, you know, once they get together, they can't separate, and they'll tend to all collapse into one. This is just a fallout of when I was playing with the mouse following. I moved the ant's movement rate really high and moved the steering factor really low. And so they shoot out before they try to get to the mouse here in the center. They accelerate past it because they don't have any approaching thing on it. I don't have anything that tells them to slow down. And then I can make it all follow around. I learned this. There's a great book resource that I followed, and there's another great resource by a channel named Kids Can Code, which was a great tutorial on this seek and wander behavior. And he also has a great tutorial on fleeing behavior. This is Dubious Insights. Thank you for watching.